This module introduced you to the very compact yet powerful way of defining reference types, with the purpose of containing data. A record is created by either creating a record class or a record struct, depending on where the data is stored. A big difference is that a record struct is not immutable by default. You can instead declare that you have a read-only record struct to make sure that this is read-only. If you do not explicitly declare either class or struct, the record created will be a class. Hence, it's a reference type. Declaring a record is normally done with a primary constructor. This creates a positional record. The properties defined in this positional syntax creates backing fields that are read-only. This produces an immutable class. Out of the box, the record makes it simple to get a string representation of the content. It also introduces value-based equality. This means that you no longer have to write the cumbersome boilerplate code for each of your domain models. That is, the classes that represent your data. You can extend a record by defining a body for it. This allows you to introduce non-immutable properties, methods, and other types of members. Keep in mind that the records are most suitable to represent data and shouldn't be used for the classes that contains your business logic. Those types should be normal classes. A good rule of thumb is to use a record when you need value-based equality. It wouldn't make much sense to use a record for the order processor. That class contains business logic that operates on the domain models. Therefore, the models can be records while the processor is a class. If it's immutability that you are looking for, remember that you can still create classes with immutable properties by using the init keyword. You learned about record inheritance and overriding the generated methods. This provides great flexibility. We also discussed that since the record comes with deconstruction out of the box, it can easily be used with pattern matching. You don't have to explicitly add a deconstruct yourself, but you could add alternative ones if you so like. Instead of introducing multiple constructors, you can specify that the primary constructor has optional parameters. We saw that this made it easier when we refactored the application to avoid a ton of compiler errors. This means we can gradually improve the application and refactor one part at a time. You learned that you can apply attributes to configure how the JSON is produced and deserialized. Adding an attribute on a variable in the primary constructor didn't work right away. We had to explicitly declare that we wanted that attribute added to the property that was generated for the variable. Records will play a big part in the applications that you build, and they will definitely make your life easier. With reference types being used in the application and the fact that you can set them to null, do you see a potential problem with that? It's just a matter of time before you run into what is known as a null reference exception. That is, when you try to access properties or call methods on a reference type that is null. With all the help we get from the language, surely there must be something that lets us find these potential issues before it becomes a problem. Next, we are going to explore nullable reference types and how it will help you avoid null reference exceptions.